Hello, pre-calcs. So I had a little trouble with my phone. Sorry about that. So I'm only now getting around to getting the second video up for you. I asked you in class, and some of you said to finish this video, but also to add some practice problems. So that's what I'm doing, okay? So we ended off yesterday in the video of Unit 10, Trig 1, Part 1. I ended off at this point with the bow ties and Cucifer. Okay, the bow ties are the reference angles that you use in Cucifer, making sure that the reference angle is always rooted to the x-axis. And think about it in terms of how you would pull a bow. Okay, you pull a bow side to side. You don't pull it up and down when you make it. Okay, so the reference angle is always positive and acute. Okay, it's always whatever this theta is off of the x-axis. Okay, so we'll do more of those on another page that I'm going to do for you. Then we also had coterminals and cofunctions, which I also put on the other page for you. So the only other thing that we hadn't gotten filled in was the exact value chart, which you've been doing for a couple of years now. So the 30, 45, 60, or the radian measures for them, okay? And then the trick is simply going 1, 2, 3, 3, 2, 1. Now, each of those numbers would then get divided by 2. Why 2? Well, an easy way to remember that is there's really only 2 trig functions that everything is based on, okay? The reciprocal functions are based on these 3, but tan is based on these 2. So it's really just 2 trig functions that everything's based upon. So there's your divided by 2. Okay, that's how I tend to tell students to remember it. Okay, although all of these are derived from a special triangle, it's actually from the Pythagorean theorem. Okay, which is why there's a square root and a 2. But just for the sake of not having to memorize, that's what I tell students to go by, okay? And then you know a radical can never be in a denominator, so it's radical 3 over 2, radical 2 over 2, radical 1 is 1, so it's 1 over 2, okay? So there's there 1, 2, 3, 3, 2, 1. Then we just said how tan is sine over cosine, so there's your fraction right there. Common denominators would cancel out in multiplication, in division, so it's 1 over rad 3, which is this. That is not an acceptable answer. You would have to rationalize it, which is why it becomes this. Now, I always still write this in case you're asked for a reciprocal, like if I ask for cotan of pi over 6, then I know it's just this reciprocal. If I use this and then do the reciprocal, I'm going to have to re-rationalize that, okay? And then anything over itself is 1, and anything over 1 is itself, because those 2's cancel, okay? So I said I had another sheet for you with a bunch of review, some of which you asked for. Some you didn't, but I did on the side board, and I don't know if everybody copied it down, so I put together this little sheet right here to go over a bunch of different things for you, okay? So let's start right here with the coterminals. A coterminal is something that is going to share the end, okay? So if I gave you theta of 320, then to get and share this end, I could go a negative 40. Those are called coterminals because they both start at the initial and the terminal ray is shared, okay? So basically to find this whole way around, absolute values would sum to 360. So to find a coterminal, if I give you theta being negative 40, coterminals would simply be add 360 and you get 320, or subtract 360 and you'll get negative 400. So if they ask you for 2 coterminals, just add and subtract 360. Okay? If they ask for more than that, you can just keep doing it again. Add 360 to this, subtract 360 to this. Okay? So that's coterminals. Cofunctions are functions that sum to 190. So co-functions, the word co, these are co-functions, sine and cosine, secant, cosecant, tan, cotan, okay? So they share that function. So if I were to give you sine 30, which you know is a half, and cosine 60, which you also know is a half, you know they're equal to each other. Because they're equal to each other, they are co-functions, and 30 plus 60 is 90. Okay? This is used to solve for theta. So I gave you this example to show you how it's used in order to solve for theta. If I told you secant of 2 theta plus 10 was equal to cosecant of theta plus 20, because these are co-functions, secant and cosecant, you could just take their values, 2 theta plus 10, sum it with theta plus 20, and set it equal to 90. And then subtract 30 from both sides and add your thetas together, solve, and you get 20. So check it. If theta is 20, it would be secant of 2 times 20 plus 10, which is secant 50, and secant of 20 plus 20, which is 40. So 40 plus 50 is 90, so it checks. Okay? So I figured let me just go over that since we did that on the sideboard. So if you want to pause this and copy this down so that you have examples of it in case you didn't copy off the sideboard, you can go ahead and do that since this is a video. Okay? All right. Then some of you had asked for some practice in Cucifer and evaluating. Okay? So here's Cucifer. The Q stands for the quadrant. Okay, so if I asked you to do sine of negative 120, you would first show a quick sketch of it to see what quadrant it lands in. Well, negative 120 lands in this third quadrant, which has a T. All students take calc. So the T is telling you that tan is the only positive. So now that I've done Q, I need to do the SFR. The S is the sign, whether it's positive or negative. Well, if tan is positive, then sine would be negative. F is the function, so the function is sine, because that's what they gave you. And R is the reference angle, always being positive acute. So what's the distance between this? It's 120 from 180. The difference there is 60. So it's a negative sine 60. Okay? In your work, you've got to show this step. All right? Then from here, the negative carries over, and then in your chart, sine 60 is rad 3 over 2. Okay? So that's a pretty simple one. The ones that you had in your worksheet were more like this. So I'm doing one with you this way. So cosine squared of 5 pi over 4 plus cosecant of 5 pi over 3 minus 2 cotan of pi over 2. So I converted each one of those to degrees, which you don't have to. I showed you how to do that on the board yesterday. Okay? So now, cosine of 225. Well, 225 is bigger than 90 degrees. So we need to take this and Cucifer it, what we did up here. So I did that over here to the side. So cosine of 225, I drew where it would be. Because it would be in this third quadrant, it's going to be a negative cosine, and the difference between 180 and 225 is 45. Okay? Whoops, I never finished that. Okay, so negative cos 45 would be a negative rad 2 over 2 in your exact value chart. So that's what I substituted here. And then if we square that, rad 2 times rad 2 is 2. 2 times 2 is 4. So 2 over 4 would reduce to 1/2, and a negative squared is positive. Okay? Then cosecant of 300, you have to think sine of 300 first. So 300 lands here, which would be a negative sine. The difference between 300 and 360 is 60. That would give me a negative rad 3 over 2, but because it's cosecant and I think sine, I have to then flip it. So I do the reciprocal, I rationalize it, and I get this answer. Okay? So I brought that answer over here, which is why this addition changed to subtraction, because it was a negative. Then we had a cotan of 90 degrees. So it's 2 times 0 because 90 degrees, I don't do Cucifer, it is a quadrant angle. Because it's a quadrant angle, just plot where it would be. Look at the ordered pair of what that would be. This is cosine, this is sine. So cotan, I think tan. Tan is sine over cosine, so 1 over 0, which is undefined, but that doesn't matter. I'm not asking for tan, I was asking for cotan. So do the reciprocal of 1 over 0, which is 0 over 1. So that gives me 0. So I plugged in a 0. That goes away. So it's really just adding 1/2 and a negative 2 rad 3 over 3. So this is your answer. Or if you had to get it into one fraction, then you would get a common denominator. This is missing the 3, so it's really 3 over 6. This is missing the 2 from here, so it's 4 over 6. That's how we got that, okay? And if you remember, that's that heart if you had to reduce, okay? So hopefully that helps, all right? And I will go ahead and put up another video for you on the graphing. Okay, see you later.